Welcome to Physics Dream Team Classroom, College Matrikulasi Pahang Kementerian Pendidikan Malaysia.
Assalamualaikum and hello everyone. Today we are going to learn about chapter 6, which is circular motion. Let's start with the overview. This topic are divided into two: uniform circular motion and centripetal force. Uniform circular motion. Describe uniform circular motion. What is circular motion, class? Circular motion can be defined as a motion in a circle or circular arc at a constant speed. Consider an object which does move with uniform circular motion as shown in figure 6.1. The object moves from A to B. This is the radius of the circular path. This is the angle which the arc subtends to the center of the circle. And this is the length of a circular arc. The value of length of a circular arc can be determined by using equation S equals to r theta, where theta is the angle which the arc subtends to the center of the circle in radian, and r is the radius of the circular path. Linear velocity or tangential velocity. It is directed tangentially to the circular path and always perpendicular to the radius of the circular path, as shown in figure 6.2. Consider three positions of the objects that move in the anti-clockwise direction. Position 1, position 2, and position 3. In uniform circular motion, the magnitude of the linear velocity or speed of an object is constant, but the direction is continually changing. The unit of the tangential or linear velocity is meter per second. The linear velocity v is difficult to measure, but we can measure the period t of an object in circular motion. Period is defined as the time taken for one complete revolution. The unit of the period is second. Frequency is defined as the number of revolutions complete in 1 second. The unit of the frequency is hertz or per second. To find the value of frequency, we can use f frequency equals to 1 over period. Let the object makes one complete revolution in circular motion. Thus, the distance travelled is 2 pi r, which is circumference of the circle. The time interval is 1 period. From the definition of speed, speed is equals to distance travelled over time interval. Speed is equals to 2 pi r over period, or v equals to 2 pi rf. If angular velocity omega equals to 2 pi over period equals to 2 pi f, therefore speed is equals to r omega, where omega is angular velocity or angular frequency and r is the radius of the circular path. The unit of angular velocity is radian per second. Uniform circular motion. Convert units between degree, radian, and revolution or rotation. Take note, guys. Unit conversion of angle, theta, pi radian equals to 180 degree. 1 revolution equals to 2 pi radian and equals to 360 degree. Unit convention of angular velocity omega, 1 rpm, which is revolution per minute, equals to 2 pi over 60 radian per second equals to pi over 30 radian per second. Okay guys, we move to the next subtopic. So next subtopic is centripetal force. First of all, we have to define centripetal acceleration. So what is definition of centripetal acceleration? Centripetal acceleration can be defined as the acceleration of an object moving in circular path whose direction is towards the center of the circular path and whose magnitude is equal to the square of the speed divided by the radius. If you want to calculate the value of centripetal acceleration, we can use the formula of AC equals to V square over R, or AC equals to R omega square and V omega. So, what is AC, class? AC is a centripetal acceleration, V is a linear velocity, R is a radius of circular path, and omega is the angular velocity. For uniform circular motion, the magnitude of the centripetal acceleration always constant, but its direction continuously changes as the objects move around the circular path. The direction of centripetal or radial acceleration is always directed toward the center of the circle and perpendicular to the linear tangential velocity as shown in figure 6.5. As we can see the figure 6.5, in any position, the direction of the centripetal acceleration is towards the center. Okay guys, we move to centripetal force. Equation of centripetal force. From Newton's second law of motion, a force must be associated with the centripetal acceleration. This force is known as the centripetal force and is given by summation of force equals to the net force equals to the MA. From all the relation, we can conclude that the equation of centripetal force is mv square over r equals to mr omega square equals to mv omega, where Fc is the centripetal force. Okay class, do you know what is centripetal force? The centripetal force is a force acting on a body causing it to move in a circular path of magnitude Fc equals to mv square over r, and it always directed towards the center of the circular path. Its direction is in the same direction of the centripetal acceleration as shown in figure 6.8. As you can see, the figure 6.8 the direction of centripetal force is equals to the direction of centripetal acceleration, and the direction is always acting towards to the center of the circular path. If the centripetal force suddenly stops to act on a body in the circular motion, the body flies off in a straight line with a constant tangential linear speed as shown in figure 6.9. As we can see from this figure, this is the point that the centripetal force suddenly stops. Then, the body flies off in a straight line. Note: in uniform circular motion, the net force on the system is centripetal force. The work done by the centripetal force is zero, but the kinetic energy of the body is not zero, and given by K is equal to half mv square equals to half mr square omega square. Okay guys, before we leave, let's retry some questions. Question 1. When an object experiences a uniform circular motion, which statement below describes the direction of the acceleration? Yeah, the answer is C. Direction of the acceleration here is refer to the centripetal acceleration. Centripetal acceleration is always directed toward the center of the circular path. Question 2. A particle is moving in a horizontal circle with uniform speed. Which of the following statement is true about its linear velocity, angular velocity, energy, and linear momentum? Alright guys, what's the answer? Before I tell you the answer, let's rediscuss. Linear velocity. When the particle moves with uniform speed in a circular motion, so the magnitude of speed is constant, but the direction is keep changing. So, the answer for linear velocity is change. Angular velocity. The angular velocity is constant since it continually sweeps out a constant arc length per unit time. Energy. Energy is a scalar quantity from E is equals to mgh plus half mv square. Energy is depends on the magnitude of speed. Since the speed is not changing, so energy remains the same. And the last one is the linear momentum. Linear momentum is a vector quantity. Refresh back on chapter 3. Linear momentum P is equals to mv. When the direction of linear velocity is changed, so the direction of linear momentum also change. With all the list is correct, so the answer is D. Question 3. A particle moves with constant speed in a horizontal circle. Which of the following quantities is zero? Okay, the answer is B. Angular acceleration. Angular acceleration is the rate of change of angular velocity. Since the angular velocity is unchanged, so the angular acceleration is zero. Question 4. An aircraft travels at a constant speed in a horizontal circle with center Q. Each diagram shows the tail view of the aircraft. The dotted line represents the wings and the circle represents the center of gravity of the aircraft. Which diagram shows correctly the force acting on the aircraft? The answer is C. When we look at all the diagram, we must notice that the centripetal force should not appear on a free body diagram. It is because the centripetal force is the net force on the system. Question 5. A body performs circular motion with a constant speed. Which of the following quantities will change due to the motion? Yeah, the answer is A. Centripetal force. The direction of centripetal force always towards to the center of the circular path. Question 6. Figure 1 shows a conical pendulum in circular motion. What is the direction of the centripetal force? Yes, the answer is A, towards the center of the circle. Awesome! Okay guys, that's all for today. Hope you are doing great with your studies. Bye. Assalamualaikum.